Alright, I promise this video will be shorter than the last one. Let's get started right away. In this one, we're looking at what are oxidation reactions. We want to know how do we recognize them, because a lot of times what the Regents will do is they will give you an equation and they'll say, which of the following is a redox reaction? So you need to be able to identify them. In order for a redox reaction to occur, we need to have oxidation and reduction. That's where the redox comes from. Reduction and oxidation. And the definition of oxidation is that electrons are lost, and we have LEO to stand for loss of electrons, means oxidized, or lose electrons, oxidized. And then we have electrons are gained for the reduction, and we have gain of electrons is reduction. So Leo and Ger are very important for you to remember, and you can see my little lion here in the front of the room. Okay, so let's focus on losing electrons first. We're going to focus on the oxidation part of a reaction. A reaction, if it is redox, can be broken into two parts. It can be broken down into the oxidation part and the reduction part. So we call these half reactions because two parts make a whole, right? So we got half reaction, half the reaction is the oxidation, and half the reaction is the reduction. If you have the oxidation part, and this will make sense when I start drawing it, if you have the oxidation part, the oxidation number of the atom or whatever you're talking about is going to increase. So let's look at this equation. Magnesium plus chlorine yields magnesium chloride. When we have this reaction, remember we spent so much time earlier this week on focusing on how to write the oxidation numbers in. So if you look at magnesium, magnesium is by itself. It's going to get an oxidation number of 0. Chlorine is uncombined as well, so it's going to have an oxidation number of 0. This magnesium here is combined with this chlorine, so we have to figure out what the oxidation numbers are. And if you don't know how to do that, you need to go back and watch my other video. So magnesium is a +2 and chlorine is a -1. Now you will see that the oxidation numbers are changing. They're going from 0, magnesium has a 0 on the reactant side, to a +2 on the product side. Because there is a change in these oxidation numbers, we have a redox reaction. So now let's take a look. If you have magnesium, which they don't have the oxidation number written in, but I'll write it in for you. The oxidation number goes from 0 and it becomes a +2. The oxidation number is going up. It started as 0. Let's see if I can, hold on. Alright, so I just squeezed that out of the way so that we can see better. Now I want you to see how this oxidation number is going up. It started as a 0 and it became, that's the arrow here, a +2. And by up, I mean this. You start at 0, +1, whoops, that's a 1, +2, +3, that's going up. And -1, -2, -3, that would be going down. So this oxidation number started as a 0, and it went to a +2, so it went this way. Now, when I write Leo on the board at school, I'm going to write it like this with the little arrow pointing up. That means the oxidation number is going up. So Leo, you always remember, if your oxidation number is going up, you have a loss of electrons and you're oxidized. Now we're going to figure out how many electrons are being lost. So we're going to do it this way. You're going to look at the numbers that are here, the oxidation number here and the oxidation number here. And there's a difference of 2 in those oxidation numbers. And because there's a difference of 2, and there's only one magnesium that is losing those electrons, you are losing 2 electrons. Alright, our last step is to write those electrons in. So we have 2 electrons that are being lost. Where are we going to put them? We need to take these electrons and we need to put them on the side that has the higher oxidation number. So a +2 is higher than a 0, so those 2 electrons have to be added to that side. So essentially what you're doing is you're balancing the charge, because the charge on this reactant side is 0, right? There's only one magnesium there and has a charge of 0. This side, the magnesium is a +2, but now you're adding two negative ones, which gives you a -2. So 0 equals +2 plus -2, which is 0 on this side, 0 equals 0. That's called balancing the charge. So now our final answer for the oxidation half reaction is going to be magnesium 0 becoming magnesium +2 plus 2 electrons on the product side. Okay, let's do the reduction now. We're going to use the same equation. So I rewrote the equation up here, but this time now we're looking for the reduction. The reduction is GER, and I always put the arrow going down because what I'm looking for is the oxidation numbers to decrease. Now if you look at the chlorine, let's get a pointer. Chlorine starts as a 0 and ends up as a -1. So we're going to go ahead and we're going to write chlorine starting as a 0 and ending up as a -1. Now notice that I included this subscript because they're the same. If they weren't the same, I'd have to balance them, but we'll get to that as we go through these videos. Alright, the oxidation number is going down. Oops, let's get a pen so you can see it's starting at 0 and it's going to -1. Went too far, but you get the idea. And now we have to figure out how many electrons we are gaining and where they go. So we're going to look at the difference between these two numbers, 0 and -1. It's a difference of 1, but I've got two chlorines here that are doing that gaining. And each chlorine is gaining 1 electron, but there's 2 chlorines. So we are essentially gaining 2 electrons. So these 2 electrons are being gained, and we always put our electrons on the side with the higher oxidation number, so they're going to go right on the left side because the 0 is higher than the -1. So my electrons have to go on that side. So my reduction half reaction looks like this. Chlorine, whoops, give me a pen. Chlorine plus 2 electrons yields chlorine with a -1 charge. This has a 0 over here. So this is my Leo, and this is my GER. Okay? Alright, let's look at this one real quick. Trying to do this as quickly as possible. We're going to assign oxidation numbers to figure out if it's indeed a redox reaction. Sodium is a 0, fluorine is a 0, sodium is a +1, fluorine is a -1. Did the oxidation numbers change from the reactant side to the product side? Yep. And because they changed, fluorine changed as well, it is a redox reaction. Now let's write the Leo. Leo means my oxidation number is going to be going up. Which one has an oxidation number that's going up? Sodium started as a 0 and ended up as a +1. So my oxidation number increased from 0 to sodium with a +1. The fluorine went from 0 to -1. So the fluorine went from 0 to fluorine -1. That means the oxidation number went down. That's my GER. Okay, so use your arrows to show you which direction or which one is which. Now let's put the electrons in. I'll put them in black. Okay, when we look at this guy right here, there's 1 sodium, and it changed from a 0 to a +1. So it lost 1 electron, and there's only 1 sodium that's doing that, so we're losing a total of 1 electron. They go on the side with the higher oxidation number, so I'm going to put +1 electron on the right side. Another little tidbit is that anytime you have an oxidation half reaction, the electrons are on the right. Anytime you have a reduction half reaction, the electrons are on your left. Alright, so now in this one, there's something weird happened here, so let me just show you. Let's get a pointer. Here I had 2 fluorines, here I had 1. I only put 1 down. I'm going to put that subscript 2 right here. But if I do that, this needs to be balanced, because now I'm saying I have 2 fluorines here, I must have 2 fluorines on the product side as well. If I left it 1 and 1, then I could just write the reduction half reaction with 1 fluorine. But because I put a 2, I'm going to put a 2 on both sides so that I make sure that it stays balanced. Okay, so we're gaining electrons. We're going from 0 to -1. My oxidation number is going down. I'm gaining electrons. How many electrons am I gaining? Every fluorine is gaining 1 electron, but I have a total of 2 fluorines, so therefore I'm gaining 2 electrons, and they're going to go on the side with the higher oxidation number. I'll write it in green. So we're going to do plus 2 electrons on the left side. Okay? So the next step, we're going to tackle that in another video because this video is getting longer. But I want to make sure that you are writing all of your half reactions correctly. All right, now off to some practice.